Question 18. Express root 3 plus root 12 in the form a root 3, where a is an integer. As I want my answer in the form a root 3, I want each one of my roots to end in root 3. My first root already ends in root 3, so I'm going to leave that alone. Look at my second root. How do I write root 12 in terms of root 3? We'll look at numbers on the inside. Well, 12 divided by 3 gives me 4. Hence, I'm going to rewrite root 12 as being root 4 times 3. Leaving the first root alone as root 3. Look at my second root. I know 4 is a square number. The square of 4 is 2. If you can square it, it comes directly outside the root. So therefore, I'm going to have 2 lots. And the inside, I've still got root 3. So therefore, that simplifies down to be 2 root 3. Now they both end in the same root. They both end in root 3. Hence, they're like terms. If there's no number in front of root, the number is 1. So 1 lot add 2 lots will give us 3 lots of root 3. Part B. Express 1 over root 3 in brackets to the power 7 in the form root b over c, where b and c are integers. My first step is I'm going to write this bracket out 7 times. I'm now going to place them into pairs. When multiplying fractions, we just multiply the tops and multiply the bottom separately. 1 times 1 will give us 1, and the bottom root 3 times root 3. If you times a root by itself, you just get the number or letter back. So root 3 times root 3 is simply 3. So every pair will give us a third. So this pair will also give us a third. Got another pair, so that will give us another third. And I've still got multiplied by 1 over root 3. Again, when multiplying fractions, it doesn't matter how many fractions we have. We can just multiply the tops and multiply the bottom separately. Looking at the tops, 1 multiplied by itself, however many times, is still going to give us just 1. On the bottom, I have 3 times 3, which is 9. 9 times 3, which is 27. And 27 times root 3 will give us 27 lots of root 3. As I was asked to give my answer in the form root b over c, where b and c are integers, on the bottom, we never leave a root on the bottom of a fraction. Hence, we have to rationalise it. As I have a single term on the bottom and I'm rationalising, I just multiply the top and the bottom of my fraction by that root. So in this case here, I'm going to multiply top and bottom by root 3. When multiplying fractions, again, we multiply the tops and we multiply the bottom separately. On the top, 1 times root 3 will simply give us root 3. And the bottom, we have 27 root 3 times root 3. If the numbers are outside, we times them outside. If there's no number outside the root, we know the number is 1. So times the numbers are outside. 27 times 1 will give us 27. Looking at our roots, if we times a root by itself, we just get the number or letter back. So root 3 times root 3, we know will give us 3. And 27 times 3 will give us 81. Question 19. Given that x squared minus 6x plus 1 is equal to x minus a in brackets squared minus b for all values of x, find the value of a and the value of b. We should recognise this as completing the square, because normally 3 terms would factorise into double brackets. So here, as we're asked to write quadratic in this form, i.e. something in brackets squared and a number on the outside, therefore it's completing the square. To complete the square, our quadratic must start positive x squared. As it starts positive x squared, straight away, I can start by opening my square brackets and place a single x inside. To find the number that goes inside the bracket, all I do is simply halve, i.e. divide by 2, the number in front of the single letter of x. In this case, negative 6 divided by 2 will give us negative 3. I then always subtract this number in brackets squared. So as it was negative 3, I'm going to subtract negative 3 in brackets squared. And I place my original number, in this case, plus 1, on the end. Leaving x minus 3 in brackets squared alone, I know that negative 3 squared means negative 3 multiplied by negative 3. And I know a negative times a negative always gives us a positive outcome. So negative 3 times negative 3 gives us positive 9. And I'm always going to subtract this number. So I'm subtracting number 9. And we place our original number again on the end, in this case, plus 1. Once again, leaving my square brackets alone, simplify my number terms. I know negative 9, add 1, will simplify to give us negative 8. Hence, to find the value of a and find the value of b, comparing my two equations, well, here I can see that a equals positive 3, because the minus is already in the question. So a, therefore, is 3. And b, in this case, is just 8, because, again, the negatives are already there. So b, in this case, is 8. Part 2. Hence, write down the coordinates of the turning point on the graph y equals x squared minus 6x plus 1. As it said hence, and we've got the same quadratic as earlier, we're using our answer to part 1 to answer part 2. To find the turning point always occurs when this bracket is equal to 0. So all we've got to do is we do the opposite of whatever number's inside the bracket. Here, the opposite of negative 3, therefore, is positive 3. To find the y-coordinate of our turning point, it's always the number term on the end, and we keep it exactly the same, including the sign. Hence, our y-coordinate, in this case, is negative 8. Question 20. H is inversely proportional to P. We always start by copying our first letter, in this case H. We then always write equals to K, and K is our constant proportionality. If the next word is inversely, that means it's on the bottom of the fraction, hence we're going to divide by whatever comes next. As it's inversely proportional just to P, hence on the bottom we're just going to be divided by P. We then substitute in our values as we want to find our value of K, our constant proportionality. Here we're told H is 10, so on the left hand side H is now 10. So I've got 10 is equal to, K is what I'm trying to find, my constant of proportionality, and it's divided by P. In this case I'm told P is 6. As I want to find the value of K, I know the opposite divided by 6, therefore is to multiply by 6, and 6 times 10, therefore K is equal to 60. Once I've found K, I can now substitute back into my original equation. Hence in this case, H is equal to, instead of having K, K is now 60, so it's now going to be 60 over P. We are also given that P is directly proportional to the square root of T. Once again, starting by copying our first letter, in this case P. So therefore P, it's then always equal to K, where K is our constant of proportionality. The K is always on the top. As it then says directly proportional, whatever we have next, we just multiply on the top by our K. So directly proportional to the square root of T. So it's going to be K multiplied by root T. Once again, I want to work out the value of K. Substituting in my given values, I know that P is 6. On the left-hand side, I'm going to have 6 equal to. Leaving K alone as K is our constant of proportionality, I've now got the square root of T. Well, the square root, we're told T is 144. Leaving the 6 alone on the left-hand side of my equation. On the right-hand side, I know the square root of 144 is 12. And 12 times K will give us 12K. As I want to find the value of K, I know 12K in algebra means 12 multiplied by K. Opposite times by 12, therefore is divide both sides of my equation by 12. On the left-hand side, 6 divided by 12 will simplify to give us a half. And on the right-hand side, 12 over 12 will cancel to leave us with K. So therefore, K is equal to a half. Now that I have my value of K, I can now substitute back into my original equation. Hence, on the left-hand side, it was P equal K. Well, K I know is now a half, so it's now a half multiplied by root T. As I want to find a formula for H in terms of T, well, a formula for H must start H equals. So I'm going to be using my equation number 1. So H equals, 60 is fine because 60 is just a number. So 60 on the top, divide by, on the bottom, I don't want my equation in terms of P, I want it in terms of T. But I know P, using my second equation, I know P is equal to a half root T. So on the bottom, instead of dividing by P, I know P is a half root T. So on the bottom of the fraction, I'm now going to write a half root T. Simplify my fraction, leaving the H alone on the left-hand side. I know that 60 divided by half, when dividing by a half, you just double the numerator. So 60 divided by half gives us 120. And on the bottom, it's still divided by root T. Question 21. The functions f and g are such that f of x equals 3x minus 1 and g of x equals x squared plus 4. For part A, we're asked to find f to the minus 1 of x. If you see a negative 1 above a function, that means we're finding its inverse. To find the inverse, I always start by letting y equal the function I want to find the inverse for. As I want to find the inverse for the function f of x, therefore I let y equals f of x, hence y is equal to 3x minus 1. And now I rearrange to get x the subject. Hence my first step is to move the negative 1 to the side by doing the opposite. Opposite of minus 1, therefore is to add 1 to both sides. So on the left-hand side, I now have y plus 1. And on the right-hand side, I know negative 1 add 1 will cancel. Hence I'm just left with 3x. I don't want 3x, I want x by itself. Well, 3x in algebra means 3 multiplied by x. So the opposite of times by 3 is to divide both sides of my equation by 3. 3 over 3 will cancel to leave us with x, exactly what I wanted. So x is equal to y plus 1 over 3. My final step is I replace x with what I was finding, in this case the inverse of f, so f to the minus 1 of x. And on the right-hand side, I always replace y with whatever's inside the bracket. So here I'm replacing y with letter x. So on the right-hand side, I'm now going to have x plus 1 over 3.